So I hope and wish everyone must be able to see the screen. I'm audible loud and clear. Now, first of all, let us understand what is demand side management and why smart grid and demand side management or demand response are interlinked. Now, very importantly today, the installation capacity of this country, as you know, it is quite huge, close to 500 gigawatt, and it is keep on increasing. But nevertheless, looking forward to less carbon footprint and green power evolution, we have decided not to go for any more thermal power plants, and all the new generation will be established through renewables. But there are a bit of challenges, as you all know, that it is easy to deploy renewable energy in any country because the installation time is almost less than a year. You can, starting from the installation, planning to execution, extract of the power is possible within 1 year. However, in case of nuclear power plants, thermal power plants, hydropower plants, it takes as long as actually 5 to 10 years. So considering the challenge, the demand which is keep on increasing, and we do not have time to wait for that, the only way left for us is quick installation of energy, and that is renewable and specific to PV. Now, there are two things here. Though the demand, which is almost half of the installed capacity today, which is less than 225 gigawatt as on today, even 45% of the required installation capacity is not being met today. We either do have exactly what we need, or we have a small percentage, less than 1% of energy deficit as on today. Why it is happening? The requirement of power is, let's say, 225 gigawatt. The installation capacity is 500 gigawatt. So that means we are energy sufficient. Why do we have actually energy power cut in the rural villages of Bihar or Uttarakhand? Or why do we have actually, energy cut during summer or extreme weather conditions where more air conditioning loads are switched on? What is the problem? Because of the intermittency and non-continuous energy available from the renewable sources. So we have installed, but they're not available all the time. So 7 p.m., unfortunately, more than 100 gigawatt of installed capacity become useless. And hence there is no energy available to be. So because of which, at a given point of time, couple of hours in a year, we are not able to meet the peak requirement. So both the peak do have certain challenges, and that is popularly known as peak energy deficit concept. What is peak energy deficit? During the peak hour, we are not able to satisfy all the customers for few minutes or few hours. To my best understanding, it was almost close to 4 to 5% of peak energy deficit before 15 years. But today, the peak deficit has reduced less than 0.5%. The peak energy deficit has reduced as low as less than 0.5%. Means we are moving forward, there is no doubt about it. It is quite good, but still it is not enough. Considering the aspiration of Indian consumers and considering the economy of the India, the way it is growing, the energy demand has to increase, and we have to be mentally prepared how to meet out. So either one thing, step number one, you put huge amount of energy so that whatever the addition of energy requirement due to economic growth can be met, number one. The number two, we can deviate the consumers from the peak period to off-peak period. So demand side management is one of the options where it suggests how we can advise the consumers to move from peak hours to off-peak hours. Very good. So I hope you all are very clear now about the demand side management. And then, but one interesting thing that I wanted to highlight here, uh, the boom in electric vehicle market Today, almost everyone is interested to go for electric vehicles. And those electric vehicles may be connected to the grid at any given point of time. We have no control. But if they are being connected and charged during the peak hours, probably this country will face a serious challenge of peak energy deficit in near future. And hence, demand side management become a very, very important concept as on today. And then why do we say demand side management using or in smart grid? Because there is a spark, there is a light in the hole where smart grid probably can help to carry out certain DSMN programs to help the Indian grid to be free from peak energy deficit. Because when you say there is a grid, that grid can behave differently, can receive instructions from the distribution system in such a manner, okay? So the load shifting become a reality. Okay, load shifting become a reality. Imagine there is a residential building which has been connected to a smart grid or being part of the smart grid and completely automated. So you can control the load, okay? Non-priority loads can be easily shifted to another hour because of the smart grid. So the main thought process behind this chapter is how demand side management can be, demand side management is important, especially country like India, in which the loads need to be shifted from peak hours to off-peak hours. That is possible smartly through modern energy grid. So that is what the thought process is all about. Let us slowly move into the load demand profile of the country, where we see there is a residential load, there is an industrial load, there is agriculture load, there is a commercial load, and there is a fractional load. Now, installed capacity of this country, very old data, 2017 data, just to have a clue that how the coal is predominating. But if you plot the same characteristic in 2025, the dynamics will certainly change. You will see the solar and wind has taken a major share, okay, of the coal generation in recent time. And very importantly, I just wanted to highlight some data of 2014-15, 15-16, and 16-17. As you could clearly see that the peak demand requirements are given to you, peak demand MAT is given to you, surplus or deficit is given to you, almost there is a deficit all the time, and you could see the deficit, peak energy deficit in percentage. As I told you before, a decade time, actually 2014-15, it was close to 5%. 5% means it is huge. What do you mean by 5%? Means 5% of the country is in dark during peak hour. Whole country used to experience a power cut during summer evening, 7 p.m. You know, we all are ready with, mothers are ready with lantern to make it okay during summer 6:30 because they knew that 7 o'clock there is a power cut. Is it okay? I think you young people might not have experienced, but I belongs to a rural village, so I know how the life is at villages. Okay, so 2015-16 it become actually 3%, and 2016-17 it become 1.6, and today probably you'll be very happy to know the energy deficit has almost nullified. There is no energy deficit, but we are not excess. We are just met, okay? So what will happen if the load increase by 2% without putting additional installation of generating unit? So my peak deficit will be, yes, if the load increase by 2% without putting additional generation, my peak energy deficit will be 2%. You see, close to 2%, because you add the load, there is no generation. Okay, so again 2% actually will be your peak energy deficit. So what will happen over a period of time, the peak energy deficit will keep on increasing until unless you put additional generation. So you put equal amount of generation, then what will happen? It is zero. But if you put more, then it become positive. If you put less, then it become negative. And considering the challenges due to electric vehicle, as I mentioned, that become a huge load which is coming up very soon. In the past, there was no additional load like electric vehicles. Everything was gas-based. But now actually there is no diesel, there is no gas, there is no petrol. If everything is electric, then imagine the quantum of electricity we need and how fast actually we have to run. So this is the future of electrical engineering in the whole industry. That next 10, 15 years, it is the year of our engineers in this country. Okay, Manmohan is quite disappointed. Why not all Tronics engineers? Huh? Okay. So, what is demand side management, DSM? Okay. So, alteration of customers' electricity consumption pattern to produce the desired change in the load steps of power distribution system. Okay. How we can reorganize the load distribution curve. Okay. It is quite oscillating, no? If you can make it flat, all of you please try to understand. You have a load characteristic. So the area under the load curve, the area under the load curve is nothing but same irrespective of the load changes. Have you understood? Very important concept. So that means I have a load curve. Okay, this is time versus megawatt, and you will get that area, which is nothing but my energy, megawatt hour. Okay. Either I use it at 9 a.m. or at 9 p.m. doesn't matter. The consumption is fixed. How the consumption of the whole day of whole Indian consumers remains same, but it can happen maybe more in the morning or maybe more in the evening. That depends. Now, if I try to make the load characteristic flat, straight, which is not realistic, but if I am able to achieve it, then what will happen? Area remains same and load curve is a straight line. What does it indicate? Imagine the characteristic time versus megawatt. The load curve is oscillating. You have two peaks, day peak and evening peak. Now, the load curve, I made it straight. I'm saying no change in load. It is constant throughout the day. The area remains same as earlier. So what will happen? You will have the load, which is less than the peak or not. That's what I'm asking. If it is flat, then the load demand, PD, is less than the PD max. Clear? So what is current PD? If it is less than the PD max, what does it indicate? When your demand is less than PD max, that means in the previous case, if you are saying there is zero energy deficit, means let's say it is 150 megawatt is my peak, and the installation is also going to be 150, then I say there is no energy deficit. But if I make the load curve flat, then my PD become 125, imagine. So what does it indicate? 25 megawatt of extra energy now being available to me. So I become almost 15% excess energy is possible because just by flattening the load curve. What an interesting concept. I think all students must be excited here actually. Try to understand just by flattening the load curve, you could see this country become excess of electricity close to 15% just by managing the behavior. All right. So that is the philosophy of DSM. So what is DSM is trying to do? DSM is trying to flatten the load curve so that you will have excess energy, or indirectly the peak energy deficit will reduce by 15%. The third important part, you can delay in your investment. Means tomorrow, if you have to put 25 megawatt of installation plan, the cost that you incur today, probably that can be delayed by a couple of years till the time. Next, actually, that straight line 125, 126, 127, 130, 140, 145, 150. Only till that time, you need not invest any money. So you are delaying the investment, You have excess energy just by making flat. So flattening load curve is next to impossible. All cannot behave. It is next to impossible, the challenges. But for some extent, we can flat it. Okay. So how do we do that? So the valley, the peak valleys needs to be chopped. And that chopped portion need to be filled with the off-peak hours. So what will happen instead of having this characteristic, you had like this, you can come up to this point. If you come up to this is excellent, which is not possible. So at least you have to be like this instead of complete off-peak and peak. So that is what the philosophy of DSM. You will not find all these things in textbooks. So please try to grasp. This is the first and last time. Hopefully you will be able to remember and convert your thought process into notes. Focuses on utilizing power saving technologies, electricity tariffs, monetary incentives, and government policies to mitigate the peak load demand instead of enlarging the generation capacity or reinforcing the transmission and distribution network. Okay, so instead of investing on generation, and for that also you have to reinforce your transmission lines because the energy need to be evacuated at a particular time is 150, sometime it is 60. But if you make it 100, then what will happen? The lines are actually uniformly loaded. You need not overload some line or you need not underload also some line. Okay. Objective of the demand side management could be maximizing the use of renewable energy sources, maximizing the economic benefit, minimizing the power imported from the main distribution grid, or reducing the peak load demand. Okay, so this is what the whole story behind your DSM. Now, these are different DSM strategies we popularly call. You have, peak clipping. So where I told you chop the peak, and valley filling, you increase the off-peak hours, load shifting from peak to off-peak, conservation, don't consume more energy, drop the load curve, load growth, during off-peak hour, try to increase the load, flexible load, they can be moved from one point to other. So these are the activities one can perform to flatten the load curve. Flatten means don't consider it a straight line. Flatten means it is almost close to a straight line. Okay. So that is what, or mathematically, if you ask me, I will say that the straight line, the area, which is a rectangle now, instead of a oscillatory curve, it is a rectangle. Okay. And this rectangle area of cross section is same as your oscillatory characteristic. And you can create an equation where you can say the PD, the straight line, and the P max and the P mean. So P max minus PD plus PD minus P mean, the summation must be minimum. The error, no, this has to be minimum and this has to be minimum. So you can formulate your own equation and do any optimization that you want to do it. Okay. So necessity of DSM, why demand side management is necessary. And perhaps actually one can even talk about these electric vehicles in the field. You can use their use their charging stations, looking forward to peak energy deficit reduction. So that means electric vehicles can be charged off peak hour. That is a very good idea. Even if you do it in a peak hour, because every zone, every substation has a different load characteristic. Try to understand. Peak hour is different, but doesn't mean that the whole country is the same. For example, if I say 8 o'clock is going to be off peak for Bhubaneswar, where I belong to. But 8 a.m. of December is not off peak for Kashmir because it is chill, all hitting loads. The load is picked up, Whole night it is not off peak anymore in winter. It is peak. So even within a city, depending upon the industrial zone, depending upon the commercial zone, depending upon the airport zone, depending upon the residential zone, every substation will have a different load characteristics. So if I have to, the vehicle is on the road, and if that need to be charged, you can connect to a substation. If you have multiple options, then you can choose a substation where it can be charged, or you can guide them to a charging station belongs to a substation, which will experience off-peak growth instead of peak growth. So that will be your objective. What is your name? हाँ शैलेंद्र का एमटेक प्रॉब्लम हो गया आज. Okay, so that is how actually you have to think, innovate. I also didn't know that. During discussion it has come to my mind. This is certainly a MTech PhD problem. All right. So when we started working on DSM, that time electric vehicle was not there, so we never thought of. But today it's become a new PhD problem, a new MTech problem, a new BTech problem, a new IEEE transaction. Possible. One has to work. Ever increasing peak demand and peak energy deficit because of continuous increase in peak demand and peak energy deficit, both are happening continuously. And that's why DSM is mandatory. Scarcity in fossil fuels, because we decided not to go for any more thermal power plant. Global warming concern, okay? And then penetration of highly stochastic intermittent renewable energy sources. They are also equally responsible for such kind of energy deficit scenarios. If it is only thermal power plant, you will not experience that. They will continuously give you power until unless there is a maintenance for half an hour in 2 years' time. Very rare reliability index. But these PVs, if there is a sudden cloudy day or maybe in different weather conditions, they may not be able to produce as desired. So these are all demanding. So now I think probably the fifth point you can all edit as the EV due to electric vehicle charging. Actually, it is necessary to go for DSL. These slides, probably I made almost a long back. That time electric vehicle was just upcoming. But that time I thought it's not going to impact much. But today I'm realizing electric vehicle can certainly impact seriously. Because there's, it's a good number, no? Previously it was thousands of kilowatts, then become megawatts, and now it is in the order of a gigawatt. So it is not a joke now anymore. Yeah. So this is a very interesting diagram. Probably I'm very happy and little proud also that I have drawn in hand a long back, and then we have printed in a different form. So this is how we visualized smart grid in 2014, 11 years back. Okay. Perhaps there was no clue, nothing, smart grid was a very rare element. 2014 it got published. That means 2011 actually we started working on this. So almost 15-year-old diagram before you, dear students. And I'll explain you what it is. It is, I'm very happy now. So what we are saying that, there is a utility distribution center. That time you remember, you see, we have done it actually architecture of DSM driven power system. We not even named it as a smart grid, but ignorantly we started working on smart grid at that time. We thought a process we have deployed for a power system, and what we thought actually today people call it is a smart grid. For the last 15 years is a long period, okay? So privilege, let's see what we thought at that time and how currently it is working as it is, So what we are saying that we have a utility distribution center and central server we call. So probably this is where actually the forecasted load is known to me. The load characteristic is known to me. The forecasted pool electricity market price is known to me. And then time of the day tariff is also known to me. And then I'm interested to carry out DSM, demand side management. Okay, so what I wanted to highlight here, why time of the day TOD is important for DSM. You see, the consumers only can move from peak hours to off-peak hours, considering there is some incentive. Vaibhav, no? Or Sailendra, Vaibhav? Sailendra. Sailendra will never move from peak to off-peak until unless he receives some incentive. Am I right? You may say, why? If it is same price, I will put it during peak hours only. Okay? But until unless you give some incentive, no one will move. But today you will be surprised. We do have a TOD price for 11 kV and above customers. There is a time of the day tariff for industry customers. That's what you might have seen in the evening hours only. All the industry run with full peak. And morning hour they do some packing, XYZ activities. They don't run the main industry. Sugar plants, if you see. Night only they are in peak. Why? Because it is cheaper during night hour. It is cheaper during night hour. So what I wanted to highlight, the time of the day tariff, you must actually observe. And based on the time of the day tariff, you can decide which load has to be shifted to which point so that it is not only making economically beneficial, but also making the load curve flatter. Now, once you have the central server, then we need to connect to smart meters, a smart meter, and we call it is DSM controller. Majorly, we consider actually commercial consumers and industrial consumers here at that time because regular customers are not price elastic. What do you mean by price elastic? Means consumers. For example, if I tell you there is a 50% off on a particular product, we all buy it, no? Well, even if you do not want it, if you give me this mobile 40% off, I'll buy it. It is not needed, but still I'll buy it. Why? Why do I do that? Huh? No, 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 nothing. Why do you buy, Baba? Or you don't buy? Status. No, no status. No, no, no. We are actually price elastic minds. Our minds are price elastic. We are attracted towards lower price every time. For example, even forget about this. Even Purana Jamana, old age also, if the grains are cheaper, people used to buy more grains and stock it. If I say gold price reduced by 50%, everyone buy gold, no? Even they like it or not. That means we are price elastic. Means if the price is cheaper, your intent to use more. Means if I tell electricity is free, what you will do? You will switch on all the ACs. Whether you like it or not, make the room very chill. Because it is no cost. The moment I say there is a cost, we switch off everything, run only fan. My dad is to actually switch off all the lights all the time because he is very careful. The electric bills should not be more than 10 rupees. Why it is 9 rupees or 8 rupees? He will calculate very seriously. And discipline, that is another factor. So we all are actually price elastic in nature. So we will consume more electricity if the energy is cheaper. So if you give an incentive, the electricity cheaper during off-peak hours, what will happen? We'll consume electricity there. As I told you, the area of cross-section of the load curve remains same. So when the area remains same and you consume more during off-peak hours, so what will happen? Automatically, the peak will actually reduce. And this is known as tariff-based demand side management. All right. Today, electric vehicles, if I take you charge during morning 4 a.m., you will not do it. But if I say it is free or 50% cost of electricity, you will put alarm, you will get up at 3:30 and put the charging. Okay? Good. I still remember actually, long back in 2005-6, I was living in United Kingdom. So that time, actually, there is a very interesting story, in UK, in 2005, excess energy used to come from actually Scottish Power, Scotland. They have installed huge wind farms. And the real demand is in London. Around 40% of load is in London actually compared to the whole UK. So all the energy has to come to UK. But in Scottish, what is happening, like, wind power they generate, but they are not very crowded. So they're not able to consume during late evening or night hours or early morning. How do they dispatch those energy being produced? You produce energy, you cannot keep it. So what they used to do, there is a sudden scheme I have seen in UK, because my place of work is very close to London. We got a scheme because that I used to have a energy meter, which is a paid energy meter. It's very big size, very new for me. I have to charge the energy meters with a card, pay some money, charge it like mobile, and hence this will function. You can see $20, sorry, 20 pounds, 19.9 pounds. Slowly it reduced to 0.2. The moment it is 0.1, you go to market, put it another 10 pounds. Prepaid meter. But we got a message that if you use electricity between 11 p.m. to 5 a.m., there is no electricity, no charge. Even if you consume, the meter is not going down. It is there. All the money is there. Means free electricity. Why that free electricity? Because that excess energy they want someone to consume, otherwise they're in trouble. So I asked, Madam, can you, because there actually all the cooking systems are electricity based, not gas based. So all cooking system is like. So I requested, Madam, can you please cook at 4 a.m.? She said, what, 4 a.m. actually? But I told the story, the same story to her. There is free of electricity, you decide. And she got up at 3:30, started cooking at 4. You'll be surprised. We haven't paid any electricity bill for last 6 months of our stay. Very rarely. Washing machine, midnight. Cooking, 4 a.m. Okay. Dry cleaner, vacuum cleaner, whole night we used to clean. Because free electricity. You got my point? And this is known as this I will teach you after that. This process is known as demand response, my second chapter. Demand response means the price, okay, help me to respond positively to the requirement of the grid. What I'm doing here is something like running an industry between 11 p.m. to 5 a.m. Are you getting my point? So millions of customers like me may be cooking at 4 a.m. Who knows? I'm not very sure about it. But I guess people must be doing it. And at least washing machine, though, you can run now between 11 to 5, irrespective of, any challenges. So now the philosophy. So what I wanted to highlight, the time of the day tariff and the DSM and the load curve, they are all interconnected. So you get those data. And the time of the day tariff is already well known actually, what is the price for tomorrow. And hence you can optimize it. So you know the time of the day. And then residential consumers, as I said, not being exposed in this country about time of the day tariff is constant price. So we are not affected. We are not very positive. We just simply do whatever we like to do. Even washing machine, we switch it on at 7 p.m. during the peak hour because there is no, huh? There is no time of the day, TOD, time of the day tariff. And very soon, I am very confident, already a lot of discussions happening. I'm not naming, but someone from a utility told me very soon we'll be having 3 level of time of the day tariff, be domestic also. So once it comes, then it's very good for us. So we have considered commercial and industrial. They are all 11 kV consumers. And you could see that commercial means I am talking about hotel industry. You must be seeing, no, their fan, air conditioning, central lights, coffee makers, dryers. So they all belongs to a hotel. Commercial consumers, this is like a 5-star hotel, you can imagine. Industrial consumer means this is like a, 4-wheeler manufacturing industry, for an example. Okay. And all the devices will be placed with smart elements. And they will be communicating with the central server. And as and when the price is low, they will get a command to switch on. The dryers of the whole hotel, you know how the hotels run, actually 5-star hotels, minimum 100 dryers, 100 washing machines, like industry. It runs in one go because 500 rooms, bed sheet need to be cleaned every day. Okay, so a lot of work actually, you know. So if you have a sensor where the washing machine will be switched on based on the command received from the central to save your money and also deviating from peak to off peak. So this is what the architecture of demand side management driven power systems. So by doing so, and then this communication can happen through GPRS, and the local communication can happen through ZigBee. That is very popular, okay? So IoT between the residential areas even today. So is it very interesting? So there is a reverse communication, you do it, you talk to the server, server talks to you, central server, am I right? So today, this mechanism is nothing but a smart grid phenomenon. Okay, so I think that's what we say demand side management and smart grid means. The smart grid can help you to reduce your peak through this smarter technology or IoT technology or GPRS or ZigBee or smart meter, whatever you call. Is it okay? Excellent. So read this article of 2014. Probably this is the first article where actually we all moved into, this is my journey towards smart grid in 2014, but we started working on 2011, I still remember. So 2011, we started working on field ignorantly on smart grid, and slowly in 2014-15, we really jumped into smart grid era. I'm very proud and happy that, you know, something happening newly and you have become part of it. You feel very happy and excited, you know. So we had no colleagues who is talking about smart grid at that time. So we, you know, isolated, you know, we all worked, and then slowly we converged and made a big team in this country. So demand side management analysis with load shifting.
One question.
Yeah, please, many questions. Why one?
When we talk about flattening, so in starting the इंडस्ट्री लोड से पैसे बड़े बड़े लोड से तो वो कैटेगराइज नहीं कर सकती थी कि गवर्नमेंट की इंडस्ट्री 8 hours, लेट्स से वी हैव 3 इंडस्ट्री, वी कैन से कि वी मे हैव लेट्स से 100 मेगावाट लोड एट ए टाइम, बट वो तो फोर्सफुली एक सब स्टेशन से हम तीनों को पावर मिल रहा है, 8 घंटे आपको देंगे, 8 बजे.
He said, who will listen? Why Manmohan will listen to my instruction?
Sir, but
Because you know,
policy बना
no policy, nahi, you cannot make it 8 hours day for you, 8 hours evening for me. My employees will be suffering in the night hours. Everyone like to work from 10 to 5. That you cannot do, no? Every individual will have their own policy. So you have to give an incentive. You cannot, that's what actually.
But after incentive also they have to force these things.
Not necessary, not necessary. Once you give incentive, you leave it. Automatically it will follow. I simply have to declare in Amazon this is 50% off. My job is done. People will run. Once you give the time of the day tariff, because we are price sensitive, no? We will automatically do it. But who will do it actually? I will do it, you will do it. But there will be third person who may say even it is 1,000 rupees per unit. I will put my electric vehicle at 6:30 p.m. only. I'm a rich person. I don't care anybody. उस तरह भी customer मिलेंगे आपको. So what we are saying, the customers are again categorized, those who are price sensitive and those are price non-sensitive. If you take a coffee in a Starbucks, 275 rupees, few people think twice before getting into a Starbucks. But few people don't think even, you know. So you cannot attract them by giving 20% discount with a normal coffee. It will not affect much. That's what Starbucks, you don't see any discount. Because they know who comes here is a customer who is not insensitive towards prices. Are we clear for that? So they will not give you discount.
This TOD will not fully help, but somewhat it will help us.
TOD will actually fully help to only those group of people, those are price sensitive.
To generator side or transmission side.
It will help, no, because your load, when your consumers will behave differently, the load will vary.
Yes.
When the load will vary, your generation will vary. The whole system will be affected just with one price change. Magic actually a time of the day. It's a revolution, people say. If you can bring residences as a time of day tariff, then your peak energy deficit will vanish. Are you clear? But nevertheless, on record actually, recording my voice, so I do not want to say a few things. I'm a very blunt person. But considering the current challenges due to free electricity, that spoils the whole philosophy of DSM. Please try to understand. Why we are not able to do TOD in this country? TOD is applicable when everyone is paying. But only if 30% people are not paying electricity due to political issues, so then you cannot implement TOD, no? Because that 30% of consumers for whom you have given free electricity, they're not price sensitive at all. Though they are seriously price sensitive group, but you make them non-sensitive by giving them free. So they will use it their own way. So your TOD will not affect. Now the TOD, there is a group of people, 30%, who will not care with price. Another 30% people, those who care, but you made them not to care. So only people like us, around 25%, they are price sensitive. So your peak to off-peak shift will not happen in bulks. Small component will happen. That's okay. 20% change.
Everyone will come here, then it becomes peak.
No. It is not that. I'm not talking about that. Everyone
Cannot.
expected to come, but this scenario, considering Indian as a scenario, which is very, very difficult to come until unless we stop free electricity to people. Okay?
Theft will also play a factor.
I don't believe on theft. I say it is loss in calculations. All right? Good. Chale. So, single objective. So, let us make the problem formulation. I think I have not asked my students, are they able to follow or not? We are talking. Any one of you can say, are able to, Chandrasekhar, could you able to follow what I'm saying?
Yes.
Okay, thank you. So, single objective, which is flexible devices are shifted to bring the actual load curve as close as to the utility or customer designed objective load consumption curve to provide benefit either utility or user. That is, minimize actual load demand minus utility specified desired load demand. Means you have actual demand, you have a actual load curve, and what you want to be, what is your desired load curve? No. You want to make it flat, but how flat will happen? To make it flat, what you to do?
Reverse of it is added.
One more is smart.
1 minus.
Actually, not 1 minus. I will tell you. It is basically the load curve. You have let us imagine a sinusoidal curve. I like to make it as a step curve. It will happen only when the positive half actually being filled at the negative half, no?
Difference, yeah.
So the difference must be made. You have a load curve. I will make a reverse load curve and merge. Then I will get a flat load curve. That is nothing but you're mathematically, you have to visualize this situation, that is minimize actual load demand minus user specified desired. So user specified is the mirror image of the reverse of the real load curve. Actual load curve is the real one. You expect to have a reverse one so that the combination will be a flat one. Okay, and that is what actually you like to. Yes, correct. Very good.
1%, it is
Yeah,
minus x only.
Yeah, that's okay. 1 minus x, okay. So objective, the second multi-objective function, how can solve this problem? objective load consumption curve is set to provide benefit to both the parties. That is, minimize actual load demand minus 50% of utility specified desired load demand minus 50% of the user specified desired load demand. This also be divided into utility and user category. Demand side management analysis with load shifting. Demand side management analysis with load shifting. We start with actually DSM constraint. The number of devices shifted cannot be a negative value. Am I right? The number of devices shifted cannot be a, it should be positive, no 5, 10, positive number hona chahiye, I cannot make it negative. The number of devices shifted away from a time step cannot be more than the number of devices available for control at that time step. Okay? Got it? Connection time of device can be only delayed and not be brought forward. That means if a washing machine is taking 2 hours time, and if I shift, it will take 2 hours only. Am I right? The device cannot be delayed more than a predefined maximum limit. I cannot make it 3 hours, you do it in 3 hours, 4 hours, 5 hours. No, it has to run for 2 hours. Okay, so these are the constraints you have to implement in your DMS for DSM formulation. I once again request all of you to go through the article which has been published in 2014. The good thing about this course, that each and every class that you learn has a wonderful publication available to you to study. Each lecture has a IEEE transaction. Each lecture, all 20 lecture has at least 40 articles to refer. So if you read this 2014 article, everything will be clearer. Now here what I am claiming, now the load curve, the forecasted load is the blue one. All of you have a look, left side. We are talking about the commercial. The blue is my load curve. There is a morning peak, okay? And then it is going, then again going for evening peak. And what is OC is the desired one, you want it to be inverse. That is what you do actually. This is what you wish to have it. How this course has been generated? How do you generate the red characteristic? Exact opposite. I mean, you can make it flat, which is unrealistic.
Green minus blue.
No, green will come at the end.
Yeah. Green we want.
Green we want. We need a flat one. You see, try to understand here. Forecasted load is known to me. But the forecast will happen tomorrow, which may happen, which may not happen, that you do not know, but you predict it. Each and every hour, you have a price. Each and every hour, you have price. Because in the past, just to make you understand, I said it is almost like a mirror image to make it flatten. Now I'm getting into a real problem. In the real problem, every half an hour, okay, or every 15 minutes, okay, see, this is given actually 48. That means every half an hour, this is one day, no, 0 to 48 slot. So there are 48 half hourly slots. But today it is 96 15-minute slot today. So 48 half hourly slot means the price of electricity at each half hour is known to me. Now what I will do, if the price is cheaper, then I will consume more. If the price is actually costlier, then I will consume less. Based on which you can have a desired, because what is the price during peak hour? Higher. So I will try to, and my desire will be low at that time, so that the mixture will make me flat. So the desired load curve will be the reverse of the price of electricity, which is also known to me. So I can plot both the blue curve as well as the red curve. And you can see closely the blue and red are almost opposite to each other. And then if I apply my optimization, now it will happen actually flat. But flat, the green one is the true load curve after imposing demand shifting. And you could see this is not really straight line, but it is certainly less than blue and more than blue during off-peak hours. So are you experiencing peak energy deficit or not? The peak energy is reduced or not? The green peak is always less than the blue peak. And hence we say through demand side management program, the peak energy deficit has been reduced. This is what the simulation result is talking about. Please refer to the 2014 article and implement it. Even today, if you reproduce 2014, still it is a good work, I will say. And you can make it more interesting by putting electric vehicles. That time you could not do it. Even today also, I have not published any article by putting electric vehicles. You can do it. Okay, good. Then we can go for different case studies like this. So objective is set by the consumers, okay, and where actually the forecasted is known to us, the desired is known to us, the red one, because there is actually not multiple variations, for industry consumers it is too much, but consumer driven DSM results for commercial area where consumers are very keen to participate. So that is how actually we can do it. And we can go for multi-objective where both consumer and the utility are participating. Okay, and you could see the green curve is actually quite almost flat actually. So after all these case studies, if you see utility driven, consumer driven, and then multi-objective. What we say utility driven, where utility will force you to shift. Utility may say, no, put sensors and tell you to go to some other place because it is very costly. Okay. Or utility may give you an indication, like I received from Scottish Power, that if you use between 11 to 5, it will be cheaper. So the DSM activity initiated by the utility. The another one, actually being a consumer, being price elastic, I myself actually, I get up, my mother actually tried to, cooperate me and say, what, whenever you are not there, I will wait and put your electric vehicle charge, but you go to your office peacefully. So that means we are consumer driven. We want to participate in the DSM. That is the second one. The third one, actually both participate. All right. So what does it mean? You see that the commercial industrial customer, how peak percentage are being reduced. It is 6.45%. That's for example, industrial, it is 5.0% reduction. Then we have actually 12% reduction and then 12% reduction in multi-objective optimization. So the maximum benefit comes when it is customer driven. If we want to follow the price, if you want to make, cooperation to the system for peak energy placement or deviation, I think that seems to be a possible one. Utility driven demand side management using DC microgrid. Utility driven demand side management using DC microgrid. So what we are doing now, very interesting problem. So utility, because we are doing demand side management, but there is a DC microgrid which is in place. So here what we are doing, when you say DC microgrid, probably this microgrid will have some batteries also. This microgrid will have some batteries. So instead of forcing the consumer to shift, if someone is cooperating, it's well and good. Even if people are not too much, price elastic, attracted towards off-peak hours because of cheaper electricity. If I tell you to uh, you know, kind of study during midnight because the day electricity is costlier. Probably we are not price elastic. I will say, no, I cannot study whole night. Am I right? So we can use the technology where we can put a battery and I want to consume electricity during night hour, okay? I can put my battery to charge during night hours and discharge during day hours. So my load is shifted, no? Drastically. So you created a battery which is acting as a load during off peak and acting as a generator during peak. So my load characteristic now will come down to this. The off peak, because of charging, it has gone here. Because of discharging, it has come here. This is what the logic. Very, very interesting problem. The method investigates the opportunities associated for utilities to optimize industrial demand for smart AC/DC microgrid environment, thus facilitating distribution utility to reduce peak energy on the existing AC distribution system. And now Shalendra can say it is not about the battery, but it is about my electric vehicles. I will guide my electric vehicles to charge during off-peak hours. You cannot discharge it anymore, but at least you can do partly DSM activity. No? So when this is gone, that will slightly reduce naturally because the area of cross section remains same. So the peak saving Salindra can achieve. So electric vehicle charging infrastructure operation to manage the demand. So this method investigates the opportunity associated for utilities to optimize industrial demand for AC/DC smart grid, microgrid environment, thus facilitating distribution utility to reduce peak energy on the existing AC distribution system. DC loads are catered from the DC microgrid, consist of solar, renewable generation, and battery storage. Load shifting of DSM strategy is implemented to minimize the gap between actual load curve and the objective and load curve utility desired as mentioned in the single objective DSM. So there is a objective load curve, utility what you desired, okay, and then load curve. Okay, your load curve is the blue one, objective is the green one, and then utility desired is the red one. So this is how it is being done. So this is what we do, and there is, as you could see, there is a microgrid, and this microgrids actually we have a AC bus, we have a DC bus, okay, and AC/DC microgrid infrastructure, sorry, architecture, and we can control the loads of AC, we can control the loads of DC using the internal controllers to make sure that the load curve of the microgrid become flatter. These are the simulation results without a DC microgrid and with a DC microgrid. As you could see, what is the difference? If you don't have a microgrid, you could have experienced a green one. But having a microgrid, it is more flattened. Could you see that? Because you have added some additional control features, no? All right. So this is, you could see the right-hand side, because of a microgrid, it become more flattened. And you can see reduction of peak demand. AC distribution system without DC microgrid, we achieved 12% reduction. However, with DC microgrid, we have achieved 19% actually peak reduction. And that is fine. The reduction in electricity purchase cost, you will have actually with without DC microgrid, it is 0.5 rupees, and in case of with microgrid, it is 2.29. So always with a microgrid in place, with having PV and battery in place, you can do a perfect DSM activity compared to without microgrid. So you can do it through price, but now you're doing with price as well as with the technology. So that's what we're talking about, demand side management and smart grid, because smart grid complements DSM and smart grid complement each other for their peak energy deficit scenario. So for India, sometimes it is a good idea if you can have wonderful millions of smart grids across the country and they respond to the central controller when to act and when not to act with a single command. So probably that would be a great scenario to flatten the load curve or minimize the peak hours. Okay, so coming to a conclusion, demand side management has potential to provide many benefits to the entire smart grid, particularly at distribution network level. Load safety DSM strategy is more reliable compared to other strategies. Multi-objective DSM strategy provides more peak load reduction compared to single objective DSM. DSM using DC microgrid with battery storage is a promising solution to feed the loads at peak hours of the present distribution system in order to get more peak load reduction. Is it okay? So with this, we come to a conclusion of demand side management. I'm happy that last 1 hour is very fruitful and entertaining, and you have almost learned something which is like a 3 years work in just 60 minutes. So that itself is a very great thing. Okay. So we'll slowly move now. What is happening today? That this is a very conventional concept. Why do I say DSM is in place almost? Before 25, 30 years to me. If you remember, we wanted to help our farmers in some rural areas by giving only one pump connection to pump the water. And we say that, and we'll give a single feeder. And farmers, they don't neither have a meter nor they have to pay. So they will do some illegal connections to switch on their motors. So to avoid that, actually, many state governments decided to make it free. Make it free. How to make it free? But free means they will run 24 hours. No, that's another problem. So they have given a feeder. In that feeder, they used to charge, let's say, between 4 to 6 a.m. And within that 2 hours, actually, you can pump whatever water you want to pump. Got it? That is also a kind of DSM program. Because otherwise, the same farmers will be tapping the live wires around actually even 6 p.m., 7 p.m. रात होने के बाद वो डालेंगे. इलेक्ट्रिसिटी वही कंज्यूम करेंगे और पीक को डिस्टर्ब करेंगे. तो सुबह उनका काम हो गया पानी, फ्लड तो नहीं करा सकते, खेती करना है. लेकिन सुबह करके अपना काम हो गया and then you enjoy. So DSM was indirectly, without knowing it is DSM, the country has experienced DSM activities before 2-3 decades. But the objective was something different. That time just to give electricity to people, but not to use round the day with a restrictive dedicated line. It will go a single one phase line will go 100 kilometers everywhere. People used to tap it in 4 to 6 a.m. And some incidents also happen in some of the states. People started actually, because they know only for 2 hours it comes. So rest of the day, whole day actually this wire become a, this become a kind of a, it's like a physical device actually. It's not electric wire anymore because everyone, all the kids grown, seeing that nothing is happening here, no bulb, nothing. And once actually by mistake, if the substation get connected during daytime, imagine what will happen. Even people used to sit on that, hang, jhola khelna, ये सब चलता था actually. गाँव में actually, कपड़ा सुखाना, because they know this is not going to work. But that's it. I'm talking about 30, 40 years rural stories actually. But what I wanted to highlight, this kind of concept were there in place even in the past. But with modern technology, we have to achieve more and more. Now, what I'm going to teach afterwards is the true latest smart grid application, which is demand response activities. So these are the references you can use. I think this is IEEE Transition Power System 2016, okay, 2014 and 2016. And third article is truly a good one, And when we worked on this, we never thought that it will be accepted in IEEE Transition on Power System that too. And people have appreciated. We have done an Indian case study here. That's for the first time I proved that it is not necessary to work on IEEE system. Even a non-IEEE system can be published in IEEE power system. Subject to your thought process, your clarity, your concept is clear. Thank you. And we'll quickly move into demand response analysis of smart grid. So DSM is over. Now we are moving to, very good. So what is demand response? How it is different than demand side management? Most of the people think that DSM and demand response are the same thing. Okay, but they're not exactly same. I will tell you how they differ. One of the key objectives of smart grid is to make the power sector energy efficient by matching the load variation along with the volatility of the renewable generation by utilizing the scalable information processing strategies. Okay, that is what we do. The idea of demand side management includes all activities which target to the alteration of the consumer's demand profile in time and or shape to make it match the supply while aiming at the efficient incorporation of renewable energy resources. So, considering the current scenario, what we are trying to do, how I can change the load curve based on the time so that maximum renewable utilization can happen and the load curve will be more effective and efficient one. One of the DSM activity, not all, is also known as demand response.
Subset of.
Yeah, demand response is part of the activity. Demand response means, you see, DSM is basically a utility-based flattening the load curve or peak energy deficit is known as DSM. When consumer participate to reduce the peak is known as demand response because you are responding. You're responding to the system. Utility side say it is DSM, consumer side it become DSM. But if the system in a smart grid environment, the utility is also helping the consumer. For example, my smart grid is showing me now the electricity is cheaper. So then utility is helping the consumer to respond. The whole process is known as, even utility is partly involved in demand response activity in a smarter way, technologically. So let us see what is demand response and how people have defined different forums. The US Department of Energy defined demand response as a tariff or program established to motivate changes in electric use by end-use customers in response to changes in the price of electricity over time, or to give incentive payments designed to induce lower electricity use at times of high market prices or when grid reliability is jeopardized. Okay? Jeopardy means when the system is really in trouble, we want the consumers to come forward and help. Main difference between DSM and demand responsive based DSM performed only at utility level, okay? Whereas the demand response is performed at both utility and consumer level separately and or together. I have just now explained. So when it is happening only from utility side, it is DSL. When it is happening either by consumer or utility or both together, then it becomes demand response.
Consumer should be at least.
Oh yes, oh yes. To achieve a low peak load curve and reduce electricity cost. So consumer participation make the peak energy deficit reduced or peak energy requirement reduced, become a demand response activity. So main aim of demand response analysis is the minimization of the total electricity consumption, reduction of the total required power generation, promote the idea of green and clean energy, elimination of line overloading. Okay. So all of you please have a look. There is a aggregator carrying many cables with him. The central part, there is a joker. Aggregator is basically, managed with all the people, they say, what, how much you need, how much you need, how much you need, how much he needs. And then finally, it will deal with the generation companies, utilities. And then it will buy cheaper price. It's like a broker and give you electricity to make profit. You are also benefited and that will also benefit. Okay, so he will do demand response activity indirectly on your behalf for the utility. Okay, and you could see how it works. All of you please have a look. There is a residential, commercial, industrial customers. There is a DSO, there is a distribution system, there is a ISO, there is a aggregator, and you could see that information flows, and this become a demand responsive activity where all the distribution company consumers actually seriously participate through. You could see the blue dotted lines everywhere. So if I give you the flow diagram of demand response, it is ISO determines the preferred demand volume and time duration that is offered. So ISO determines the preferred demand volume and time duration that is offered. So it says this is the time I want this block of energy to be either purchased or sold or shifted, whatever it is. Then aggregator receives the load data from the ISO. Aggregator is an agent. He understood, oh, there is a cheaper energy block available. It will say, you please buy that, okay? During off-peak hours, it will say cheaper block. So aggregator identify, oh, this is the block energy. So he'll say, I need 20 megawatt hour between 4 to 6, okay, AM of the day, and this is the price. Once aggregator selects the consumers for their participation into the DR program, depending on the availability, he will come to A, B, C, D, ask who need price with 20 paisa per unit, 20 paisa per unit. You all say yes, yes, yes. Then he'll fix it, okay? Then accounting the number of interested customers agree with the proposed demand response means what will happen? That means this block that government has given or the ISO is given to you, there's a flexible block. So that means you have to listen to their instructions all the time. If they say switch on, no, you provide some flexibility. Even if the light goes for 5 minutes, you should not fight for it because that is what the conditions are. Because you are not paying really true money, okay? It is free, but if it is available, it is free. If it is not available, some small interference, you must accept it. Accounting the number of interested consumers agree with the proposed demand response. What it says demand response means I will hand over my mobile to them. The plug connected to this mobile may charge or may not charge will be decided by the utility. I am agreeing to that. That's what it is cheaper. Are you getting my point? The aggregator optimizes the load demand and the new load demand data is reported to ISO and the local distribution operators. You got my point? So this is how the loads are being managed actually. So DR applicability on different consumers. There is one category known as industrial consumers, high energy consumers with peak load of few megawatt. Loads have critical temporal dependencies and must be scheduled with high time precision. Thus, DR programs should be capable to monitor and control the loads in millisecond timescale. Furthermore, security issues are particularly important as the load profiles or load shapes is highly confidential and computation sensitive. Moving to commercial consumers, main power consuming equipments are heating, ventilation, and air conditioning HVAC, lighting systems and electronic devices. The reduction of the power consumption can be achieved by either the adoption of energy efficient building technologies and or by the control of the building's energy consumption behavior through price elasticity, as I told you, of power demand. Now moving to residential consumer, DR program applied on residential customers are specially named as Home Energy Management System, HEMS, which is very popular, where the smart meter is being part of this whole demand response activity. And you identify there are 20 components, 20 equipments in the home. out of which actually 5 you do not want to be flexible because TV I like to watch as and when I want. But my washing machine and heaters are being, water heaters can be managed through ham system. So you automate everything. So 5 devices will follow the demand response instructions and 5 of them will be flexible to you. So that is how the ham system works in modern houses today. Residential, the electric vehicle also could be part of the ham system, okay? Because that plug will be, it is, you dedicate to smart meter, there is a sensor to that plug. The plug will have a sensor. The plug will be activated only when the smart meter desire to have it. And the smart meter will make it operational only when the price is cheaper. Right? Good.
Sir, that's maybe silly question.
No, no, not silly. It's a very interesting question. Go ahead.
Okay for like Indian countries, but developed countries like maybe US.
No, even in India, it is possible.
Like for India, it's okay, but like though you are having a smart home and all, for them some price of electricity matters because they are rich people, they are having all those smart things in home.
Oh, no, 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 no.
You have to perfect.
Okay, okay, okay. I think
हमारे
that,
लिए ठीक है.
no, 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 no. That is a wrong concept. You are saying rich people are actually more energy conscious. Today, probably for me, if I talk about renewable power, we are not that serious about it. I don't mind it's a thermal or this. I want to have some cheaper electricity, that's all. But rich people are actually conscious. Means they say we are ready to pay 5 rupees extra if required for technology to promote green energy. Are you clear? So I think if I tell you about not using a plastic bottle, isn't it? I think perhaps rich people can afford, but they carry their water bottle more seriously, not to use plastic. So if you see in the market today, in malls actually, when rich people only carry a bag of their own, they don't prefer to have a plastic thali.
They're more
Conscious, so it is not about the cost actually. You see why they are actually not about electric bill. They're excited about the philosophy. They're excited about the nation's benefit at long run. They're saying, I am participating in an activity which is, my statements are very important now. They're participating in an activity which reduces the peak energy deficit. Indirectly, by reducing 5% of peak energy deficit, 5% of the population is now getting access to electricity. You see the link. By adopting the new technology, they're giving electricity to people, those who are not having access to electricity. So that is how so that is the philosophy basically. I mean, Delhi, people are actually very much interested to buy an electric vehicle with a hope that the pollution will reduce. They don't see the cost. Otherwise, if you see 30 lakh rupees for Mahindra, that electric vehicle, it's a dabba, there is nothing. No heaviness, no machine, nothing. But why they're paying for the technology? Because they believe that Delhi become cleaner. Isn't it? Got it? Very good. So I think it is working then. So it is not about, they are more conscious, the philosophically, all right? And also, residential DR programs are most complicated because residential load is mixture of different kind of appliances like critical refrigerators that you cannot switch it off. It is not price sensitive and you cannot do that. Thermostatically controllable AC heaters, deferrable but interruptible washing machines. Mean you can defer from morning to evening, but you cannot completely take it out. Again, deferred devices like dryer electric vehicles, they are also deferred devices. The DR program should provide plenty amount of incentive for people to participate. It is not about actually rich or poor. It is about conscious and irresponsible people. If people are conscious, they will participate. If you're irresponsible, then if you take a cup of tea isn't it? Some people actually take that cup till the dustbin comes. Some people knowingly throw it, assuming that it is, how does it? When go the campus also, even our engineering graduates are not sensitive. You find many cups floating here and there, but they could have dumped it in a proper way. It is what you want to do it is something different, isn't it? So similarly to me, demand response activity is all about how sensitive towards, and perhaps I will go one step ahead. Forget about all the technology. I think we power engineers must go to villages and conduct half-day workshop, educating the villagers to run their washing machine during off-peak hours as a defer load. इतना तो कर सकते हैं. देश कहाँ चला जाएगा एक्चुअली? जो लोग आज की डेट में एक बल्ब पढ़ने के लिए नहीं मिल रहा है ना, उनको बल्ब लगे जलेगा क्योंकि कटेलमेंट नहीं हुआ. ये सोचने लगा तो हो गया, देश बन गया है कि नहीं? भारत इज इन ऑर्डर. गुड. So DR communication requirements, quality of services, interoperability, scalability and flexibility, finally security. No problem. So we'll go for different optimization objective. You can either go for minimization of electricity cost, one of the objective, maximization of social welfare, that is the profit that you can gather, minimization of aggregated power consumption, minimization of both electricity cost and aggregate power consumption, both the maximization of social welfare and minimization of aggregated power consumption. The last one. This is how the DR optimization happens. Now moving to classifications of DR program. DR programs are classified mainly into 4 levels. DR based on control strategy, DR based on price, DR based on load. Okay, we can do demand response through different control techniques. We can do DR based on the price elasticity, and DR based on the load actually. So when you do for control strategy, it could be either centralized or decentralized. And DR based on price could be demand price based or incentive and penalty based. I may say if you consume electricity at peak hours, you'll be charged more. Or I can say if you consume during off-peak hours, to be charged less. Okay, and dynamic pricing, as I told you, there is a price variation, time of the day tariff. And DR based on load is task-related DR and energy-related DR activities. So these are the control strategies. You could see how people are centralized control and decentralized control that happens through a philosophical way. So in case of centralized control, the response decisions for load activation are only tackled by the power utility. Overall load profile improvement by considering network security is done. User privacy is violated due to complete monopoly of utilities. Now moving to decentralized control, utility only get to know about the net consumption of the consumers. Utility designs pricing signal to influence its users. User schedule loads on its own depending on the received price signal. So when I talk about DR based on price, dynamic price based demand response offers customers time varying prices that are defined based on the cost of electricity in different time period. These prices are designed according to the load level of the entire system. Incentive/penalty based demand response offers fixed or time varying incentives or penalties or payments to customers that obeys or violates DR contracts during period of system stress. Dynamic pricing means, there is a time of use, I already told you. Critical peak pricing that I can do, peak load pricing, and we can have a real-time pricing. Real-time pricing means it's very too dynamic actually. Okay, every 5 minutes actually the price can vary. Moving to conclusion of today's lecture. Successful implementation of demand response program is possible if the users participate into it willingly without compromising their comfortable lifestyle. ये सबसे बड़ा conclusion. Well, I should not feel that if I have to get up at 4 o'clock to charge my electric vehicle or washing machine, I must get up and switch on 2 switches and sleep. Okay, irrespective of the benefit that I get. Then only the country will grow actually. All right. For example, we say don't waste food. I think rich people are more food conscious. Rich people never throw. I never throw rice actually because we are conscious. But you go to any restaurant, you'll find average people throwing plates of food like left and right. I'm having everything, but I don't throw. People don't have anything, they throw more. They pick up something which is not required. So once you do willingly, so why people are doing it? Those who are even not necessarily when poor people, some are very sensitive, they clean the plate nicely and they feel that if let us not waste, someone should eat. That is the philosophy. The electricity is also similar to that. At least someone get bulb to glow for the kids to study. That thought process has to be there in mind. So DEAR program does not ensure same amount of benefit for all the participating players. That is, some may be incentivized, whereas some can be receiving penalty. कोई एक को तो penalty लेना पड़ेगा, कोई एक को The employment of DEAR relies on the reliable, robust, and secure communication system. Choice of efficient energy price structure is the main key factor to attract the users towards the DEAR program. All of the above DEAR schemes should be unbiased. That is, fairness is the basic need of. So with this great note, we are coming to an end, and these are few references that you can refer. I'm very sure, all right. So I think with this note, please read the article 2016 IEEE transition on power system, Nand Kishore, NP Pari. Probably that will talk about both the demand response, demand management, smart grid, all the concept would be available. So with this note, we come to an end and thank you very much for your wonderful attention. Take care. Bye for now. If you have any questions, please do not hesitate to ask.
Thank you, sir. So please ask any questions. So I think today's lecture was very much elaborately explained by sir. Many new things I that I also came to know.
I think because we have gone slow, everyone must have understood. But still, if you have any questions anytime, please drop an email to Dr. Manmohan so that it can be clarified at any given point of time. But I'm very confident if you go through the PPTs, they are self-explanatory, most of the cases. So if you read, probably you'll be able to understand. Thank you very much and have a wonderful day. Bye-bye for now.